current computer. So we have 40 slides. Hopefully these 40 slides will be good enough to get you started with MongoDB. Okay, let me grab my pen. Okay. Introduction. NoSQL stands for not only SQL. Some people mistakenly read it as not SQL or something that excludes SQL, but that's not the case. It's not only SQL means SQL itself covers the structural database. So the rationale behind having this name is it's not only covers SQL, that means the structural database is also, because that's the structural query language, right? SQL. Not only covers the structural query language, structural database, it also covers unstructured, and you will get to see. So SQL-like query concepts on non-relational database, or in other words, I say non-unstructured database. So there is no schema, no table, right? You do not need to set the schema. You do not need to set the table, right, up front. And later, I will show you examples that you can throw any type of data structure you want, okay? So one of the rows or tuples can have 5 columns, another row can have 10 columns, so you can throw anything else you want, right? It's that level of flexible. So we'll get to see that. So once again, document is storing databases, and you can possibly do more research to figure out that it also supports storing images, videos, and other complex type of data. But we will look into document related databases. And I already shared a JSON file with some documents, right? I don't know how many of you have already started to play with that, but we will go over once again. So document and sub-documents hierarchies without using relational database. So you will have a document inside another document inside another document. So how you can use that type of hierarchical document structure, and how you can do query using in NoSQL. We will get to know that. So here, what we will see in document databases is key value pair, right? Because you all know that in a relational database, we had what? We had with the column name, which is name, and the name of the person, right? So this is what we will be referring. This column name will be referred as the keys. And the values that we'll be storing under the column names will be called the values. So in other words, all the documents that I will be storing here will have key value pair. That means the name of the field or name of the column, it could be just name, and the value for this one could be John, right? So this is how I will be representing the data, rather than representing in a table, because when you're representing in a table, you need to have a fixed schema. That means your number of column needs to be fixed up front, okay? Unless and until you change your schema, you're not allowed to insert a data that does not have anything else for this one. So that will prevent you. But here, it doesn't follow any schema. So for example, you can have one sample or one row with 4 of these keys, right? Another row that has 10 of these keys. So it doesn't restrict you to schema structure. So whenever I'll be referring to the word key, that I mean that those column names. Whenever I'll be referring to the value, that means I'm referring to the actual data or actual instance of that column or actual instance of that value of that key. Okay. No defined structure or schema for storage, and is storing and retrieving database on keys. So we'll be heavily depending on the keys. Same way we used column name in relational databases, we will use the keys. Okay. That's what we will get to see. So there's a basic question. So we have on one hand, we have relational database management system, and on the other hand, we have NoSQL, what to choose and when to choose, okay? The first question you can ask that, what do my data look like? Is it a tabular data, rows and columns? Then you probably consider a relational database. Importance of database transaction accuracy, that means does it have a fixed schema? If it has a fixed schema and you are kind of bound to use a fixed schema and you want to follow fixed schema, go ahead and use relational database over NoSQL, right? How important is the speed of the database? Now, this is what I got from online. I cannot explain or I cannot tell you the technicality behind this statement. If speed is the most critical factor, consider NoSQL, because it does provide a lot of scaling and significant performance boost. That's kind of interesting, okay? If you are for some reason struggling with relational database, you can possibly reformat it into NoSQL and you can get a significant performance boost. So what happens when data are not available? That means you have a lot of missing values, a lot of nuns, right? If that is the case, then your relational table, your relations will end up having a lot of cells with missing values. So essentially that will be a waste of space. Okay, so if you consider each of these space holds certain amount of memory, so that will be a waste of space. So in that case, NoSQL provides better solution, because if certain fields or if certain keys or if certain column names do not contain any value, don't include those key names, don't include those column names, don't include those fields, right? Just simply don't include it. So because NoSQL allows you to do so, because it's very flexible in terms of its structure, okay? How is the database being used? Do you frequently write data? That means if you're making frequent transaction, who is making the noise?
I don't have, I see this one.
How is the database used? Do you frequently write data? Because in transaction business, you frequently want to write something else in your data set, right? The most likely relational database would be a best choice. Or in other words, on the flip side, you may want to frequently read the data, right? So you have already stored the data, but oftentimes you want to read the data, then NoSQL could be a better choice. Okay, got it. Okay. And or you can have a split. So for transaction and frequently update related data, use relational database, and for blog post and web contents, use NoSQL, right? So you can, set what type of data, how you're going to use that data, whether or not you need a performance boost. Based on all these considerations, you can decide to move to NoSQL or relational database. So MongoDB is basically the server. Okay, most popular agile and scalable NoSQL database. And once again, you might be asking, okay, well, this hybrid and relational database class is supposed to cover object-oriented database, object relational database. How does MongoDB fit into this course content? Okay, so you will get to see that we're essentially dealing with objects. Data objects, database objects, collection objects, document objects. So all the notations you will see are similar types of notation you see in object-oriented programming language. You have similar type of path expressions and similar type of methods you use in object-oriented programming language. You will get to see those type of things, right? So data objects are stored as documents in a collection. We will talk about collection, we will talk about documents, we will talk about database in a while, but but at the end of the day, we will see that things are all represented in objects and you are just using some sort of method. Those who have already looked into assignment 4, perhaps you have seen 3 different methods I asked you to use to do some sort of query and get some results out of that. Okay, so once again, this is object-oriented representation. This is another object-oriented database if you want to consider, but this is a non-relational database. Okay, instead of table, rows, column types, data need not be predefined. Okay, so you don't have to predefine any structure, any skeleton, or any schema whatsoever. Documents are stored as binary JSON or BSON objects. JSON stands for what? JSON stands for what?
JavaScript object notation.
JavaScript object notation. Okay. I have already shared a JSON file with you, so you will get used to that. Document oriented, same data format at the server and client side skills. Because like I mentioned, that JavaScript is the native language. You can use JavaScript as a native language on Mongo shell, right? So that helps you to represent this data not only in JavaScript type format, but also if you want to connect that database with some web server, and the web server is also built using JavaScript. So that allows you to have a seamless transition between your database server and the web server. Okay, because it doesn't require the data transfer from table rows and objects, right? Because we had this problem in relational database. Because relational database, my data model was relational model. We had to transfer, or we had to map that relational model into some sort of object model, right? But here, we don't have to do that because our data structure is in a JSON or JavaScript structure. And if you're using the JavaScript programming language of front end, you're using the same language that is same object notation or same data structure that is supported in that programming language. So in that way, you do not have to do any type of transformation, or there isn't any impedance mismatch that we mentioned previously. And that's why we wanted to have some sort of hybrid object relational mapping. So here we do not need that object relational. So great for a website backend storage and high traffic data, user comments, blocks and new posts, high performance, availability, and automatic scaling, right? Can be scaled up horizontally across multiple servers without compromising the performance. So one of the biggest motivations behind using NoSQL, you will find in the book and textbook and reference books or whatever. There are a lot of online resources that it scales really well, okay? And it can handle many data across. So let's move on. Okay, so the first thing I'm going to show you, and I showed you this data structure. This is a terrible looking data, right? It's hard to decide what's going on here. So this is basically a screenshot from a JSON file. So the JSON file that I shared with you, if you open that JSON file, which is called mydata.json, you will be probably seeing something similar to this. It looks kind of an unstructured, but there are some keys and their corresponding values. So this is what we call the key. In other words, whatever else you call as column names, this is the column name, or this is the key. We'll be referring to key, because using the column name will be misleading because we're no longer dealing with tables. This is another key. So as you can see, this key has something nested inside and starting with a parenthesis square bracket. And this is the value, right? So the value for this trend key is essentially another piece of document, right? I don't know where it ends, but we need to figure out where the lossless square bracket ends. Okay. So this is my key. And inside this key, I have tons of values for this key. And inside this key, inside the value, I have another key. And that has another value, right? URL is a key, and that key has a value, which is the URL that we're looking into. Promoted content is a key, none is a value. Query is a key, this is a value. Tweet volume, by the way, this is a, if you download the Twitter data, this is how it looks like, okay? This is the name, probably the name of the user, and this is probably the URL of the Twitter account, whether this is not a promoted content or not. So, there are a lot of metadata user data, user information. A lot of data are stored in this key value pair nested structure. And apparently it may look that, oh, this is something not easy to manipulate. For example, how would you do some sort of query when you see this type of data? So what you can figure out is the keys, and the keys basically tell you that this is probably one document. This is one document, and it's starting from another name. This is another document. And where is the another name? This is one document. And where is another? Here is another name. So this is another document. So each of these entries will be referring as document, right? And this whole thing will be a collection, right? So in other words, I'll be repeating this thing again and again. So collection is what we call the table. And table is a collection of what? Tuples, right? The rows. But here, instead of calling it tuples, we'll be calling it what? Document. And these are my individual document. And each of these document can have these key value pairs, right? So it takes you to document mining or text mining and that type of research and application. So once again, these are the fields and these are the values that you want to look into. Now, one of the things is if we can nicely structure the fields and keys and values and everything else with proper indent, you should be able to see that not all keys are available in all collections or in all documents, right? So this is what you will see. So if I nicely restructure this thing with proper indent, now I can see that under this trend, we have a bunch of documents. This happens to be the first document. This is the second document. And in that way, we will have multiple documents. So each of these document is representing, let's say, the Twitter account information of individual user, right? And one of the things that is very obvious here, like I mentioned in the last class, so this is after nicely structuring the key value pairs. You have these keys, and these keys in this first document. But if you look into the second document under the same, let's say, collection, you see that the promoted content, this particular key is all along missing. It's not there. Now, this is something we do not allow in relational database, because if you get rid of one of the columns or one of the column entries, you're violating the schema, right? Because you have to stick to the schema. When you're inserting a row, the number of elements in that row must be equal to the number of columns, right? That was the strict rule we had in relational database. But as you can see here, there is no such rule. I mean, it's okay to not to have, that particular key like we have here, okay? And then we will get to see more along the line, okay? So this is the idea. So installation, I have provided in PDF. I was getting quite a few questions from you over the weekend that I'm having trouble installing this and that. I was able to fix some of your queries and some of your troubleshoot some of your installation issues. But is there anyone else who would like to share any quick experience just to let me know or let the class know that you were not able to install and you're still having issues? Anyone else? Or everyone is good with the installation? Good, everyone? If you haven't tried yet, that's okay. You don't have to comment. But let's say you have made a substantial effort, right? You spend hours and hours and hours, but you couldn't get your MongoDB server up and running. If that is the case, then you really need to talk to me or reach out, and we can get a solution for you. Anyone? Everyone doing good? Good, everyone? Can I hear someone saying okay?
I'm good.
Yep, I'm good. I'm good.
Okay.
Relatively content at this point.
Okay.
I just want to know how to import the JSON file.
Okay. Okay. So was that not mentioned in the installation guide? No? How to import the JSON?
It may.
Yes.
Okay. I also have some slides here. We will go over that in a
Okay.
bit. Okay. So one piece is the Mongo shell, right? And even before you run the Mongo shell, you have to get the MongoDB engine, which is the MongoDB server, Mongo, the daemon up and running, right? And then you have the shell. And another thing that I do not plan to cover here, because this is the only lecture we will have to go over so many things about MongoDB. So this is similar to SQL Workbench, but I recommend for now, just go ahead and use command prompt and command window, because this is useful. This is something you need to know. So MongoDB management. So the first thing you have to do is you have to connect to the DB server, right? You can create, view, and delete databases. You can create, view, and delete collections. You can create and delete documents. You can query documents. You can view statistics related to the database, okay? And here are the three possible ways you can do MongoDB management, okay? Number one is you can write one line at a time, or you can copy paste a bunch of command lines on MongoDB shell, and you can run over there. This is one thing. Another thing you can do is you can compile all the JavaScript script, right? So let's say in order for you to create a user account, you have to write 6 lines of code. So instead of executing all these 6 lines, copy pasting on the server, one of the things you can do that copy paste this the commands in a JavaScript script and execute. We will show you how to do that. Okay, we have an example of that. You know how to do that a little bit. You have seen, you will get to see that, or you can use the Compass graphical user interface. So because probably this is the easiest of the three. So we will look into these 2 examples, how you can write all the commands in a JavaScript and execute the JavaScript rather than typing one line after another, okay? So these are the 3 ways we will get to see. Okay, now I need you to kind of look at this hierarchy, this tree very carefully. This is the database server, okay? And under one server, you can have multiple databases. Even right now, when you have your bare MongoDB server, when you write show DBS, it shows you 3 databases, right? So those are the 3 databases. And as you know, each of the database is what? When it's relational database, it's a data collection of what? Tables. But here we will be saying these are collection of what? Collections, right? So each database will be or can be a collection of what? Collection. So we'll be calling it a collection. And under each collection, we will have a bunch of documents, right? So documents is something that is equivalent to rows and tuples in each table. So this is what we know as the table. Okay, my pen is behaving weird today. And this is what we formally know as the rows. So these are my documents. So you have to keep this in mind. Whenever you're trying to do some sort of query, you have to start from here, navigate all the way down to here. So for that reason, you need to create a database object. And using this database object, you have to create a collection object. And using the collection object, you can further do some sort of query within that document. And we will show you all the steps today, but you have to keep this structure in mind. Okay. Any questions so far? We haven't gotten into it yet. Okay. So the MongoDB shell is an interactive JavaScript shell, and you can run JavaScript on that shell. Setting up user account. So you can set up user account, you can create a database, you can do query, you can do anything else, or can load and execute JavaScript. So if you have a JavaScript file, and you can just simply execute just JavaScript, and that will work as well. So for example, this is within the MongoScript shell. And if you have a JavaScript whose name is myscript.js, you can just type myscript.js and it will execute the JavaScript. It's that simple. Now on eLearn, I have shared a JavaScript which is called my user, I believe, .js. Did anyone get a chance to look into this JavaScript? If not, you can just go ahead and check it out. Okay, try to open it using some sort of editor to see what we have inside, because we'll be discussing this in a bit. So one of the things you can do is, let's say this JavaScript file has 6 of those lines. You can run those lines individually, or you can compile all the lines in a JavaScript and run the JavaScript. It works. You know, show DBS, it shows the list of databases in the server. And you know, use MyDB. So use MyDB. MyDB is a placeholder for the database that you are interested to use at this point. And you had similar type of syntax in MySQL, right? When you use my database name, so it switches to that database, so that from then and on, you can use the collections and documents of that database, okay? And there are 2 methods, right? So one of the things you have to remember, that the moment you type this command, use MyDB, by default, it creates a database object called a DB. That's the default. It behaves as a database object. For example, if you want to access the collections within this MyDB, the thing you can do is this particular command will instantiate a database object or database handler, in other words, that points to this particular database. So then if you just use some sort of path expression dot my column, okay, it will give you access to the my column that is under this MyDB. But the generation of this DB object will be very implicit and very default, because right after writing use MyDB, you can just go ahead and use this DB handler, because it will be created automatically. Unless you want to rename this handler or rename this object, this will be the default database object that you will be using to access your collections. And once you have access to the collections, then you can get access to the documents using path expressions. So as you can see, these are all following typical object-oriented notations. So once you create this one, you can just go ahead and add user. And that user, you will get to see that, you can set the users, different types of users. Some users could be admin, some users could have just the read privilege, but they are not allowed to write. We can set up those users for accessing those databases. We can remove those users. We can change their admin privileges by writing comments. There are a whole lot of things we can do, okay? These are the 2 methods. So once you instantiate this DB object by calling this command, you can use add user method. You can use create user method. And here you just put the credentials or the information about the user who will be accessing the database. I will get you. So both of them work equally. There are subtle differences in terms of their usability, flexibility, but either of these 2 will work, okay? And MongoDB objects, before managing MongoDB, you at least need to know what? The database object by default is DB. The moment you use the database, the moment you have a database, you switch to a database, this DB will be instantiated there for you to access the database content, right? And then you need to create a collection object, right? I highly recommend that you go to these 2 links to see what are the different methods that are supported, what are the different, contents, or what are the different features you have for MongoDB. And these 2 I basically use these two links, MongoDB documentations for download to prepare these slides. These two links are more than enough. You don't need to buy any book. Hopefully you won't need any internet resources. This is very well documented. Okay, and this is what it's shown in the Mongo shell methods, right? So you have collection. We'll be talking about cursor in a bit. You have the database, and there are other concepts that at this point we will not be using. For example, user management, role management, and so on and so forth. I will try to give you a full overview. Okay, so database object in MongoDB shell. Let us try to look into that. So to connect a database in Mongo shell, what do you type? You just use the database name. Okay, what this command will do, that either this command can create or connect to the DB name database. So if the database is already existing, it will connect you to that database. It will switch over to that database. That means the pointer will switch over to that database access. Or if the database does not exist, it will create that database. Okay, and it implicitly, like I mentioned before, implicitly sets the DB object or instantiate the DB object and sets this one as a pointer to this database content. Okay, it happens implicitly in the MongoDB shell with the attributes related to the database in use, such that if you just type DB right after this, if you just type db.getName, it will print the name of the database. Why am I using this DB? I never mentioned this DB. Well, that is implicitly created the moment you switch over to a particular database. Okay, so this is the method call will display that. This particular method call will display, as you can see, this is an object. This is the method call, object-oriented database. Right? Will display the database name. Right? This is that simple. And then for user management, for example, you can create user. You can drop user. Once you have this DB object, and this DB object is basically pointing to the database in use, then you can use this additional method to change the user credentials. Okay, drop all users, stop user if you want to remove a single user. These are all from the documentation. It creates a new user and so on and so forth. Another thing that is interesting, and that what I was trying to promote when you guys were doing the SQL Alchemy thing, that instead of saving the username and password in the script or doing anything of that sort, how can you prompt an user? For example, now you have your database. Whenever someone will try to access your database, they will need to provide some credentials, some username and password protected. So when they will be using the database, there needs to be some sort of prompt for the password and username. Okay, you can set that up by using password prompt, right? This is that simple. So the first thing, before you create the database, let's say you want to decide, first of all, who will be the user of this database and what type of access and what type of user privilege or access privilege I'm going to provide to those users, okay? Not only it allows you to create, view, delete user accounts with restrictions, it can allow you to change them as needed. So let's say I have a database which is called My Rental Database. And one of the things I can do is the moment I use this command, implicitly, this object will be created by default as a handler or as a pointer to this My Rental Database. I can use a method called addUser, and I can provide this username, password, and roles. By the way, these are all MongoDB specific keys. You cannot put, instead of PWD, if you put something else different, that will not be accepted, because addUser is a built-in MongoDB method. And the fields or the attributes that we have inside these methods are also specified by MongoDB. So these are built in. You cannot change that, right? So here you can see that I can set the role. Read, write, that means you're allowed to both read the data and write the data. And I can put the DB admin. Okay. By the way, these are also what? MongoDB specific command, MongoDB specific keywords. Okay. So there are a whole lot of keywords that you can use and set to set the data. Now, one of the things I did, if you go to, is there anyone else who checked the my user.javascript? Did you check? Anyone?
I did.
Okay. Do you see something similar to this one?
Yeah.
Okay. So what happens here, this is one of the two things you can do. You can copy this whole thing and paste on Mongo server or Mongo shell. This is one thing you can do. Or what you can do is you can copy this in your JavaScript and then just execute the JavaScript. Just every time, just type myuser.js. That's it. Okay, you can just go ahead and try that out, whether it works or not. Okay, I'm going to leave it up to you. And then you can type show users. Okay, that will show you the user profile. The users were allowed to use and think as needed. If you want to, if you want to remove certain user, you can just remove the user by what? The username. Simple. Let's see. Alternatively, you can write the JavaScript script and execute in MongoDB shell. Okay, it's up to you. But I would not recommend, copy pasting this one in the server. I would like to organize and put everything else in a script, and then I would like to rather this JavaScript on MongoDB shell rather than typing line by line. Okay. Now let's move on to the connection object. Okay. So that was one way. That was one way to connect to the database server, to the database. What do? You just use database name that will automatically create an object DB. You use that object to do a whole lot of things. You can also create database. So here is another way to do it. You can also create a database object using the getDB method. So this is another MongoDB specific method on a connection object. By the way, this is a connection. Don't confuse with the collection. Collection is a different thing. So one of the things we can do is we can create a connection object and use that connection object to connect to the database. And we can see some example. For example, the JavaScript code below does the same thing as shown in the previous slide. So what we are doing here, so this is in JavaScript, right? You can put these 3 lines in a JavaScript and execute the JavaScript. Okay, so this is the same local host MongoDB server. So you're creating a connection. You're creating a new connection object, right? And you're putting name of the database, and you're getting a MyDB object that represents the database. Now, if you do not use this one, what is the equivalent to this? If you just write use MyDB, and automatically you have the pointer ready, DB, and you can use just get name, right? This is what you have seen so far. And this is just an alternative. So if you want to run it through JavaScript, what you want to do is you want to create a connection object, use this connection object to create a database object. So in this case, the database object is something that user is explicitly defining rather than implicitly generated by the system. Okay, and then you use mydb.getName, and you can use db.getName. Right? So that's the only difference. So this is a kind of equivalent to doing this. Okay, I'm just showing you another way. So this is what we call the connection. We can create connections, and we can use that connection. Okay, so this is the Mongo constructor. It creates a new connection object, and this is exactly what it did over here. And this it connects to a MongoDB instance, and to a specified database on that instant. This is exactly what the connection was used to do. And you can use get database. That means this Mongo will be what? A database object, and it will return a database object. And you can use that to see the get names and other things. All right, it's pretty simple. So now we know how to connect to the database, right? So we're at the top of the server. I have to pause this a little bit. So anything that will not be covered in the final exam, you don't have to show those as examples in the cheat sheet.
Correct.
So
Okay.
That's pretty obvious.
So there is nothing cheat sheet to upload in the Dropbox.
Okay, we will get to that. Okay, so we have plenty of time for the final exam. We will get into that. I'm still to create those folders. Okay, let's come back. Let me see if my trackpad is working now. Okay, looks good. It's behaving well. For example, JavaScript code. So we have seen this example, right? Now, collection objects. You have to remember this should be at the top back of your mind that we have the server, and server is connecting with what? Bunch of databases, and databases will be connecting to a bunch of collections, and collections will be connecting to a bunch of documents, right? So we know how to access the DB. We have seen those examples, right? Now we need to understand the column collection objects. Okay, the collection objects represent a collection of documents, same way a table represents a collection of rows of tuples in MongoDB, right? So collection object is primarily used to what? Access the items in the collection, add documents. This is something important. If you need to insert a document, you need to use a collection object, right? If you want to query a document, right? Where in my document I have the Twitter user who are 25 years old, 25 and above, who are 25 years old, right? So if I want to query those documents, I need this collection object. So this is very important, right? So from database object, you have to create collection object, and that collection of object will give you access to the documents. Okay, to access a specific collection with a database, you can access using the DB object, right? So first, the DB object will be created. And once you have the DB object, you can use this path expression, collection, count. This will obtain what? Count the number of documents in that particular collection or in a view. Okay, count documents, estimate document count. So there are a whole lot of built-in methods that you can use to do quick query on this collection or quick query on the table. So we'll see some of them as we go on. You can create a collection object using get collection, okay, method on the database object. What is an example of a database object? So DB is a database object, right? And my collection object will serve as a handler. So once you get a new collection, you can name that collection as a my collection, my call. And that will be by calling this method against this DB, it will create a new collection, or it will create a pointer to that collection that I'm interested in. So this object will serve as a handler for applying methods on those collections. Pretty simple. So the first thing you have to do is this DB is a database object. We know how it is created. Then you use this path expression, db.getCollection, use my restaurant. For example, your table name is my restaurant, and this time it will be your collection name is my restaurant. It will create a handler or an object that you can use to access the specifics hidden inside this my restaurant collection. Okay, so if I want to, so this is from your homework assignment, right? Do you follow this one? This is from your homework assignment. In your homework assignment, I told you to apply these 3 methods, and that's it, right? You answer questions, 3 questions probably, or only 1 question. So it performs a query in the collection. So this is same as what? This is same as doing some sort of SQL query. So find is same as in SQL we wrote where. This is same as where, right? But in the parentheses, we have to put some sort of conditions in the where clause. And the same way we have to put some parameters, we have to pass some parameters, some query objects. Later you will be seeing that we are passing some sort of query objects into these find methods to be able to do some sort of query, okay? And then you, of course, you have the insert. Let's say you want to insert a document into this table, you can insert. You want to do some query. So these are equivalent to tables, right? These are my tables in MongoDB, right? But table in a sense that this is the table counterpart of MongoDB, but these are not actually table, these are totally unstructured collection of documents, right? So this is how you can, so the first thing first, you create the DB, and using the DB, you have to create a collection object, and using the collection object, now you can use that collection object or collection handler to do a whole lot of things in terms of doing queries, getting some information from that collection and whatsoever, okay? So like I said, the links I shared with you related to MongoDB documentation, it's there, very well written. So what does it do? It creates a new document in the collection. We're inserting a document. Insert one, inserts a new document in a collection. Insert many, insert several new documents in a collection, okay? So it's all about getting used to these methods. The more you get used to these methods, the better you become at this thing. So there is nothing fancy here. Okay. Once again, let me recap this whole thing, right? This tree is very important. You have server, underneath server, bunch of database. Under each database, you have bunch of collections. Under each collection, you have bunch of documents. Okay. In order for me to get to the server, what do? This is the connection to the server. Okay, what is the next thing? You want to get, this is what? This is my database object, right? If you do not use this one, that's okay. You can create the DB. This is my what? This is my collection object, right? This is the collection object that I'm using. So I'm using the server connection object to be able to get the database object, and then using the database object to be able to get the collection object, right? And once I have the collection object, I can comfortably do my data manipulation and data query whatsoever in a specific document. So is this hierarchy clear enough in terms of the tree and the code you have next to the tree? Good, everyone follows this? Any questions?
Yeah, thank you.
So managing MongoDB user accounts, and if you want to create a new user, you just use .db create user, okay? And you know what to put here. Those are the specifics you have to provide about the user credentials. Drop user, you want to get user, returns the user information of a specified user, update the user data. For example, one user has read access, he wants to be given both read and write access. How would you do that? Okay, password prompt, whole lot of things you have that you can do, and you can use this password prompt inside the database authentication, right? I showed you those examples. So these are some of the things, okay? So a JavaScript has been shared to demonstrate an example of DB create user, right? You have the JavaScript, which is called myuser.js, okay? And this was what I was planning to give you as a homework assignment, but those who are interested, you can go ahead and test by yourself. But because we're done with the homework assignment, we're supposed to have 4 homework assignments, and that's all we have. So your homework assignment could be as follows, right? Add 3 users with 3 different read-write roles, right? Show all the users on MongoDB shell. Use and demonstrate DB get user. That means after inserting or after adding 3 users, you can just print what are the existing users. Use and demonstrate update user method to update any specific user. For example, the role of a specific user has to be changed. Show the updated user credentials. If you want to do drop user, you can do this thing and show the updated list of users after dropping that user. So, you know, these steps, if you practice these steps, it will give you an idea and experience that, you know, how you manage. And then I was planning to give you a bonus that you can use and demonstrate the password prompt, right? Because you do not want to set your database access unprotected. You want to set up some username and password, and you should prompt the user to provide password, and only then should allow. So those are some of the things I was planning to give in a homework assignment, but if you want to forget about it, you can forget about it. If you want to learn more and practice along this line, you can go ahead and practice along this line as needed, right? Managing database objects. So we can drop the database, we can get collections, right? What does it do? It returns a collection or view object used to access the collections with names that are not valid in Mongo shell. Create a collection, right? It can create a new table or new collection. We are calling it a view or new table. We can get the collection info. That means if you want to get the table info and collection names and so on and so forth, we can. So let's create some collections, okay? How can we create a collection? So creating a collection is equivalent to creating tables, right? A collection can be created using database object DB. Once again, we have this database object DB. If you are using MyDB or something like that, by using connection, you can use that. You can also use that. So any database object can be used to call the create collection method, because this collection named column name will be created where? In that DB, in that database, okay? You can create a collection object by my collection, DB get collection, and this will be a collection object, right? This is just the creation of that collection. And if you want to further manipulate or further get access to that collection, then you would like to create an object that points to that particular collection. And now I can do a whole lot of, because this is a collection object. Now I can insert documents using this collection object into that collection as needed. So once I have this object, I can do a whole lot of things. I can do insert, I can get the total size, I can get the count, I can get the stats, and so on and so forth. So you can use the collection object to access all methods defined for collection. So if you go to MongoDB documentation, you will see that the documentation page is laid out like this way. So you have all the methods that are defined for collection object. Okay, what are those methods? Stats, counts, and you will have full list of methods that are defined for collection objects. And then you will see another page where you have all the methods that are defined for what? Database object. Okay, so if you study this material in this way, keep the methods that are defined for database object separate from the methods, study them separately for the methods that are defined for collection objects, probably that will be easier, because at the end of the day, we have to keep this thing in mind, this whole thing, right? And this is how you want to navigate through, okay? And once again, these are the methods defined for collection objects, right? Another thing you can do, so this is a database object. When I'm using this path expression, this is now what? This is a collection object, right? And with this collection object, now you're able to use the methods that are defined for collection objects. Okay, you can go try to get into different things. Returns an array of documents that have distinct values for a specified field. Definitely, we have to pass something else in this parenthesis, right? Because those are the examples we will get to see in the next couple of slides. But for now, if we want to have a documentation on the list of tables or list of methods, this is something you can use, okay? You can draw a specified collection from a database, things like that. So inserting document to a collection. Now that we have the collection object, we can use that collection object to insert, right? So first of all, once we write this command, it will automatically create a database object, and we'll be using this database object to create a collection object. So this is my collection object, okay? And this field can be, so you can go ahead and look into the details. So what type of data are supported in this particular collection? You can specify those things. You can just go up and look it up online. But if this field is kind of an optional, if you don't want to keep it, you don't have to specify that. And then you can type show collections. That will show you all the collections. And this is how we would possibly insert a document, right? So what I have is inside this parenthesis, what I have is a document. So a document is nothing but key value pairs. So this is my key, this is my value. This is my key, this is my value. This is my key, this is my value, separated by comma. And as you can see, you can visualize this data in a table that has 3 columns, right? So this is just, I'm inserting one row here, right? Where this is my age, this is my GPA, this is my department. Here, this is CS, this is 3.56, and this is 32. So what I'm doing here is these are my keys and these are my corresponding values, and this is what I'm trying to insert by using comma separated key value pairs.
So Dr. Savadon, computer science will be the collection, yeah?
No, computer science is not a collection. Computer science is a value.
Oh, it's a value, okay.
It's a value. So this whole thing within this curly brace is what? This whole thing is just one document. This is just one document, right? And what is a document made of? If you look into this key value pairs, it is made of what? Keys and its corresponding value, right? What is key? What is the equivalent of key in table in relation? Is the name of the columns, and value is basically the entry for that column. So computer science is a value for the key, which is called department, right? This is the same type of thing that I showed you in the Twitter, right? So in the Twitter, we had the name as the key, some John something else, and then you have the URL, remember the key, and you had www something 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 something, right? So in that way, if you can put it into a key value pair, in Python, we call Python's dictionary. It looks similar to hash table. You can take that and insert as one document into this column, right? And when I'm inserting against this column A object, which is this one, I'm essentially inserting in the column that is named what? My call A. But I'm using this handler object to be able to insert the data into this my column, my collection, right? This is what I'm doing here. Then you can get the stats. This is something in your homework assignment. You can do find, and I'm going to show you find. So if you simply write this find, what it will do is it will show all the documents, because I didn't provide any specific constraint on my search, constraint on my query. So if you just write column.find, it will show all the documents, okay, that are stored in that particular collection. Okay, so inserting a document. So since I don't plan to type and run on shell, what I wanted to do here, because that's going to take some time going back and forth between the PowerPoint slides and the code. What I have here is the actual code I typed and I tried to run, and I'm sharing that with you so that at least you can see what's going on. So the first thing is when you write use admin, okay, it switched to the DB admin, and automatically what will happen? It will create an object called DB, which is a pointer, which is an object pointing to the admin database, right? And then I can use this DB object and get the collection. So now I have a my collection object, which is pointing to what? This collection named my collection A, right? So, and then what I can do here is the moment I have typed this one, then I can do what? Once I have the collection object, I can insert document to that collection. And this is one example, right? And you will, once you insert this one, you will get a message popped up, right? Result inserted and inserted one, okay? And then I'm inserting another one. And then I'm trying to insert another one, and then I got an error, right? So I have a couple of questions for you. Okay, why there is an error in the middle?
NY isn't in parentheses, quote.
Yes, that's the parenthesis that's the missing, and that's why you're getting an error. And sometimes I know these are very minor and silly errors, but when you get this type of error, don't get frustrated, don't give up. Okay, thinking, oh, this is difficult. Okay, let's move on. What is the name of the database, the collection, and the collection object? The name of the database is what? Admin, right? What is the name of the collection?
My column here?
My call A.
And what is the
My
name
call
of the
A.
collection object?
Michael.
My
My
call.
call, okay, just to make sure. How many documents are there in the collection? Just to make sure. How many documents we have in that?
Just one.
Just
One.
one.
And
Sure.
then we've got error.
Okay, but error, we fix this error later on here, right?
There's
So
two. We have two.
Okay, then two.
yeah, so there are two documents, right? I think that's clear what I mean by document and what I mean by collection, right? What is the difference between the two documents inserted? Do you see any difference, structural difference, schema-wise difference?
Yes,
Yes.
the second one have a lot of keys.
Okay, so we have age here, GPA here, department here. We have status here, but we don't have address in the first document. But here we do have an address, and which happens to be another document. So address is a document inside this particular document, right? If you try to do something similar in relational or object relational databases, this would have been totally forbidden. You see what I'm saying? But here you have the flexibility. You can just insert any type of key value pairs or any type of things as you want. It's not going to match the structure of one document with the structure of another document. This is acceptable. And that's why I wanted to raise this question so that you understand the flexibility of MongoDB, flexibility of NoSQL. All right. Can you comment on object ID? Is it ordered? Can you use your own object ID? So here, obviously, each of these documents will be identified by an unique ID, right? But as you have seen in OQL, is when we're instantiating an object, right, in an object-oriented database, the object ID is something implicitly created, implicitly generated, rather than expecting user to assign those unique IDs. So same as this, in this example, if you just simply type my call, which is the column collection object dot find, what will happen? This is essentially equivalent to SQL syntax what? Select, asterisk, from what?
My call.
My call. This is same as this one. So it's going to print all the documents. And in this case, it was printing all the rows. So here you can see that the MongoDB server basically assigned unique object identifier. You see these numbers. System, by the way, the system, right? And as you can see, this entry, this document looks pretty different from this one because you have an address key here. And the other document does not have this address key. Okay. So the reason I'm showing these screenshots, because if this was simply some typed sentences on PowerPoint slides, you won't believe it, right? Now you know what to expect when you will be typing on MongoDB shell, that what type of results that will come out. So instead of going over that typing and programming exercise, I'm just sharing the screenshot. This is what you expect to see, okay? And that allows me to cover a lot more topics in a smaller. So we're on slide number 23. We have total 40 slides, right? We have a long way to go. Okay, so let's code. Let's look into some of the things that we want to play with. And you know what this is, right? So this is a collection object we're creating, and we can show the collection and so on and so forth, right? So a couple of questions. How many documents have been inserted here?
four documents.
Were we able to
Sorry?
successfully insert this one?
Oh no, we didn't get any prompts yet. So just three.
Okay.
The fourth one caught an error.
Okay. Do you see any difference in the keys across the documents?
Yes, address again. The last one.
What about this one? School, GSU, and Uni, LSU. These are the keys. You see, too many flexibility, too much liberty is sometimes bad, right? Some user may be inserting the document where he wanted to represent a school as a key that is named Uni. And this is acceptable because I'm not going to match that simply because it was Uni there, it has to be Uni over here. No, there is no such restriction here. You see the thing? The address is obviously another thing, but you know, this is something to notice. That's allowed, right? Because you have too much flexibility here. Okay, let's move on to the next question. Do you see any difference in the number of keys in the documents? That's obvious, right? This one has more number of keys, one extra. Anything else you notice? The rest of the things look pretty similar. Are the differences in number 2 and number 3 acceptable in relational database? This is not acceptable, right? That means if the name of the column is a school, for all sort of entries, you should use a school. You cannot use anything else. But here, if you use something else different than the school, that will be represented as a separate column, a new column, right? That's okay. You can put anything else you want. But when you'll be doing the query and you are looking for a specific field in school, then you will be missing these two documents because these documents do not have the school field or do not have the school key, right? So that's something to keep in mind. Why there is an error while trying to insert the last document?
It says there's a missing curly brace.
All right. Where would you put the curly brace? So this curly brace is over here. This is over here. And okay, this curly brace does not have its match, right? Is that correct? So that this curly brace
Yes.
should be where? Inside here, right? Is that correct? Because the parentheses will stay outside, and inside the parentheses you insert the documents or nested documents using curly braces. So that's the curly brace that's missing. Okay, syntax error. So if you get to see this error, it's very easy to debug. And I see some students, when they see an error, they don't try to understand the error. They just share the error with the instructor. Okay, why am I getting this error? Well, the error message is self-explanatory. It tells you why you're getting the error, right? So please do take help from that message if you happen to get this type of
Dr. Samad, why do we have the that's another curly brace over there?
Which one? This one?
Yeah.
So most likely what happened is I put this curly brace after this parenthesis.
Okay.
This curly brace should be inside, right here, right? To
Yeah.
match with this curly brace. Okay?
Yeah.
Okay. Because insert is a method, right? Insert is a method that should start with a parenthesis and it will end with the parenthesis. And inside is insert, you will use curly brace to represent a document, comma, another curly brace to represent another document, comma, another curly brace to represent another document. And inside this document, if you have another document, for example, address is another document inside this document, you can have the key name and you can just go ahead and use another curly brace. So we are using curly brace to represent the document, individual documents.
So you can insert 3 or 4 documents in just one command. Okay.
Yes, we'll see those examples. Okay. So another thing you can do is you can type this myCallObject.find.pretty. There is a pretty method, right? Once you type this pretty method, this, I don't think I have that example. Once you use this pretty method, what will happen is something like this. Let me show you. Let me go back. This will happen. So if you don't use pretty, you will see something like this. Okay. If you use pretty, you will see something like this. Okay. So oftentimes, these documents will be so much nested and so hard to visualize for human beings. You would like to use .pretty. And once you use the .pretty method, it will be shown in a way that is comforting to human eyes. Okay, that's all about it. Okay, so that's what I mean by pretty. So you have a whole lot of methods you can study by yourself and dig into it. Okay, now let's move on to the importing a JSON file to MongoDB, right? How many of you were able to import the JSON so far? I know PK was able to comfortably without any issue. Anyone else who tried?
I did. I was able to without any issues.
Okay, so like I mentioned, you need to have this Mongo import application. So is there any other way to import other than using MongoDB? Maybe there is. I'm not an expert. You can Google it out. If you don't like MongoDB or you're looking for, Google it out. So you need this. You need to run this Mongo import application. Then this is your DB. This is the database you want to import, and then you have to provide the name of the collection where you are importing the JSON file, and then just to go ahead and give the path of the JSON file, and it's going to be saved as JSON array.
One small suggestion for the students, before they do the Mongo import, just to make sure do a DR, to get the list of the directory, to make sure they have the Mongo import in the directory before they run this process, this command.
Right. So students who are shell Unix user, you can use ls, and those who are Windows user, you use directory to see what are the files that are located.
If they have all the Mongo import and other files somewhere else, they can bring it and copy to the bin, and then it will allow them to run the Mongo import.
I mean, I'm expecting that my students are already comfortable, because we have, I mean, even though this was a database class, I mean, just imagine how many times we had to use the server. We had to use the, command prompt, we had to use the shell, and we had to use this type of thing, right? So by now, you know how to navigate through different file paths using command line, and it shouldn't be an issue at this point, hopefully. All right, so make sure that you have the Mongo import application in the binary folder, and you just follow the instruction path, and a sample JSON file is provided. You will get to see what's there. And if the collection is existing with previous documents, the command line will append a new document to the collection. So this is kind of interesting. If the collection is existing with the previous document, so every time you execute, it's gonna append the new document every time, right? So you may have multiple instances of this thing under that collection, right? So you can check that out. So here it's showing that it was imported successfully. If you still have issue, you should follow this one. And these are some of the collection methods, pretty. When you open this mydata.json file, you will see that the text is almost cluttered everywhere. So that's why after loading it here, you just use find.pretty. It will demonstrate a pretty structure that is easy, that is comforting to human eyes. Okay, and then you can count. You can use count to count the number of documents as you have here. Okay, let's do some document query, right? We haven't seen any query yet. Let's look into the query. So before I get into the query, let's take a 10 minutes break, right? How about that? And then we will come back. So right now it's 3:46. We'll come back at 3:56, okay? Thank you.
Dr. Samad, quick question.
If I want to dump the JSON file, what I have to do is, what is the name of my database?
Admin.
Here, what is the name of my database?
Oh,
DB01.
DB1. So I should have, right, DB1, right? And then collection, was that a collection or connection?
I think it was collection, if I'm not.
Right? It's a collection, right?
I think it
Yes,
was
it's a collection.
Yeah, it was.
It's a collection. So you go back here, you go back here, you go, okay. So what will the next line? You should write collection. And what is the name of the collection here?
Col1.
Col1. And then just go ahead and give the path of the JSON file. That will be treated as a document and saved in that collection. Okay, so collection is a collection of what? Documents.
Okay, thank you, Dr. Samana.
All right, let's take a break. 3:50, we will come back at 4 o'clock.
Thank you.
All right, so let's do some query. We have created, we have gotten connected to the database server. We have a database object ready, and using the database object, we're able to either create a new collection, or we're able to create a collection object. And using that collection object, we'll be doing a lot of beautiful things. We'll be doing a lot of queries as needed, right? So the reason we're separating the documents across different collections is when we're planning to do some sort of query, we want to do the query within a specific collection of documents, right? We want to confine our access and insert and everything else within a collection. And we have to keep in mind that we are not dumping documents directly to the database. We're dumping documents to a collection, which happens to be a part of the database, or happens to be one of the constituents of the database. That's what you have to keep in mind. And you have to keep that hierarchy in mind. Okay. Okay, and green. I shouldn't use green, I should use a blue. Okay, so remember at some point I mentioned about the thing that is called cursor. We'll get into the cursor. So one of the things we have to do here that we previously saw collection objects and methods of find, and this is what simply does is what? It will create, this find will create a cursor object, okay? And find returns a cursor object, not the actual document at this point. What you will find is you can also use find one, which returns the first document that matches the criterion. Okay, and you can have cursor objects like pointers that can be iterated to access a set of database in the database, right? We'll look into this cursor object. So we will learn to manipulate cursor object to access actual documents, okay? Let's look into this. So you need to define the query object. Remember, you had this find, and inside the find, we had to pass some parameters, right? So what we will be doing here is we will be creating those query objects, basically the query statements, basically the criteria, basically those constraints, and then we will be passing it to this method, find method, to be able to do our query, right? So let's look into this generic finding. So for example, if you do not want to use select asterisk, right? Now you are trying to do select something where from, and you're specifying this where. The moment you have some parentheses, parameters passed, that is basically the where clause, right? That is basically the where clause. So you're being selective about the documents that are stored in the collection. Okay, for example, to search and match documents of individuals, where I'm specifying this field, that means I'm interested in only those documents where the city is Nashville and the salary value is greater than 10,000. So in other words, if you write it in a SQL, I can write something like this: from my collection, right? Because now we don't visualize as a table, we visualize it as a collection where what? City equals Nashville, and, or you can write and, my salary greater than 10,000, right? This is exactly what we're going to query on MongoDB, right? And let's see the syntax, okay? This is the syntax. So first you create the query object, and that query object needs to be passed as a parameter to this find method. What is this query object? Once again, this query object looks like another JSON object, right? The query object. So the object is like the JSON object. So here you have the key, which is the salary, right? And inside this salary, you have another kind of a document where you have another key. What is this key? This $GT is a MongoDB specific keyword, which stands for greater than. So this whole notation is, in other words, this whole notation represents what? Salary greater than 10,000. This is how you write this thing. Okay. And comma, you also specify the city. So I'm interested in only those documents that satisfy this criterion. Okay. And then GT is query operator representing a relational operation greater than, and this is a list of query, right? So you have a whole lot of, this type of keywords. For example, $GTE matches the values that are greater than or equal to. So the moment you put E, that will include an equal to. NE matches the values that are not equal to, right? And if you use the key and if you specify some value in this query object, that means this is essentially what? When the key value equal that particular value, right? It's the same thing. So the equivalent notation of this one in my SQL would be what? City equal. Was it equal? It's just equal, right? Nashville, right? Very simple. So the example query object will be city, and the city is the field, Nashville is the value, right? So what is the next step? Once you create this query object, you pass this query object where? In the find, and you will get all the documents that have this type of thing. So this is the table, and I have shared the link for that table where you have all the query operators. Equal, greater than equal. This is in, and you know what in is, right? In is nothing new. Those were from SQL you have used. LT represents less than equal, and you have some Boolean logical operations, and not, nor, or, and so on and so forth, right? You can just go ahead. It's just a matter about getting used to this syntaxes, right? So another example, you can do query and find a value. For example, I'm interested in only those documents, only those documents where the job is full-time, right? Simple. This is equivalent to what? This is equivalent to writing full-time. Same thing, okay? Or if you want to use in, that means query based on an array of values. This is the array of values. Finding documents with names that start with ABC. Okay, so this is how you can have it. Query based on size of a field array, right? Finding documents with names that have 5 letters. So this is my name. So I want those documents where the name field has what? 5 letters. This is how I represent. So it's a matter about practice. So if you want to be a MongoDB engineer, or manager, or whatsoever, so you have to spend some time into this, and then you will get comfortable with the syntaxes and everything else. The more you do, the better it becomes. Query based on all contents of an array. Find documents with names that have all of the following characters. So that's why I'm using names, colon, ampersand, all. So it will grab those documents where the name has all of these 3 characters. Okay, simple. Let's see what we have. So this is another interesting topic where you have a document nested inside another document, right? You have seen this, and you have seen that address was a document, and you can have an address inside an employee document with its own fields, such as this address as a document, it has its own fields, own keys, for example, this type of thing, right? So for that reason, what you have to do here, and if you want to access the address, which happens to be nested inside this employee document, so what you have to do here is address is the key of this employee document, and then you have to use this path expression. You use .street, this, which is very similar. You have seen this type of use this type of path expression before, and nothing difficult here. So query for documents that have a field existing. So with no restriction for a structured schema, like in relational database, there may be employee documents with no salary field at all. You have seen this example, right? To query documents containing only salary field values. Let's say I have 100 documents, and each of these documents is representing some personal employee information about individual employees, right? Some of those employees or some of those members, for example, at TSU, right? So at TSU, let's say we have a database with 100 documents representing 100 people, corresponding to all 100 people. Now, not all 100 people will have this salary field. Those who are staff, those who are faculty, and those students who are getting paid, they will have the salary field. And some students who are not employed on campus, they will not have the salary field. But it's okay. You can, welcome all of those people into one single database, right? So let's say you want to find the documents of people who have the salary field. So what you write is salary colon $exist equals true. Okay. And you get all the documents of people who are kind of employed, and that's why they have their salary field, right? So on and so forth. Okay. So let's look into the cursor object. So let's recall the find method that yields the cursor object below. And one of the things you can do that you can use that cursor object, okay, because once you do some sort of query, that query will create a cursor object. And using that cursor object, now you can count the number of documents following the query. So after doing the query, let's say 57 out of total 100 documents satisfy that particular criteria, those particular criteria in that find condition. And this cursor object will be basically pointing to those 56 documents. And then you can use cursor.count. So it will count the number of documents that satisfy that find condition. And it configures the cursor to display in an easy to read format. I didn't show you an example output of .pretty method, but you can try it by yourself because you have the mydata.json. Once you load it, you can just use .pretty. You should be able to visualize this in the very end. So we have a reference table for other cursor methods can be found in this. So let's see document access using the cursor object, right? So let's say we already have, so let's say we have this DB, we have mycall, okay, and we have find, right? And I have specified something else, something very specific, right? And based on that, here, I will have a cursor, which is a pointer object. Pointer to what? Pointer to only a subset of the document. Because what does a query do? A query essentially gets you a subset of the rows, a subset of the tuples. So after launching this query, I will get a subset of all the documents, all documents I have in my call. And this cursor will be pointing to that subset of all documents. And then one of the things I could do is I can do sorting. And it's pretty simple. If you want to sort the document based in an descending order of the age, you put -1 here. And this is the key. This is the value. And if you put the value -1 when you're sorting, it will do the descending order. And if you put 1 or +1, it will do the ascending order sorting. Very simple. Same way here, in case where if we have multiple documents with the same ID, the first thing is you, if you have one name with multiple IDs, then you first consider the name, and using that name, you get it, you sort in an ascending order. And then if you have one name, if you have multiple names, if you have multiple documents with the same name user ID, then you can resolve that taking the ID into consideration in the descending order. So this is how we did. You did the similar thing. And another interesting thing here is you can use a JavaScript for loop or JavaScript function. And this is a JavaScript. I'm not a JavaScript coder. Those who are coding in JavaScript, you can tell me better, right? So here, what this function is doing, JavaScript function, it's creating a for loop, right? Cursor.forEach. So if you want to read one document at a time, you can use this JavaScript function to read one document at a time. And username, and this is what you want to output, right? So document object dot the key, the name. So every time it will be iterating through that cursor, using that cursor. So this cursor is basically pointing to a collection. Okay, so by using for each, it will be iterating through those documents located inside a collection, and you can access those fields as needed in a native JavaScript programming language. So essentially, you can stay in JavaScript, and you can write MongoDB query and MongoDB management command and everything else within JavaScript without requiring any type of transformation whatsoever, because these are all the same. Okay, manipulating documents, add and insert. We'll see some examples here. Document manipulation methods are accessed via collection objects, right? We have to create the collection objects, and you saw that insert, right? So here is an example where we'll be inserting multiple documents, right? You can insert a document object that is JavaScript type, right? So this looks like kind of JavaScript documents where you have, this is a JavaScript type object where you have the key and value, key and value, key and value, key and value. So this could be a JSON, or this could be a Python dictionary. Okay, this could be a Python dictionary. They have the same format. So key, value, key, value, key, value type of a structure. So this is a TSU. This is a Austin Peay State University, and this is a University of Memphis. Okay, they look pretty similar, right? At this point, is there any difference? I don't see any difference. Zip, zip, you have a strict number. I mean, so here is an example where you're kind of following a schema all across, right? You're dealing with this structure. You can consider this as a structure because I didn't change the number of or name of the keys here or the fields here, right? The size and everything else is similar. So what do? The first thing is you have to create a connection. By the way, this is what you should write in a JavaScript script. So you can say my database script.js. This is what you should write line by line. So first you create a connection, and that connection will connect you to a database, and you get a database object. And using that database object, so this is the name of the database, right? This is the name of the collection. What is a collection? This collection is all about all document about universities, right? That's why this could be a university table, right? But here we are calling university collection. So once you have a handler or an object to connect to the university, the next thing is, this is my collection object. I can insert what? all three together. This is a JavaScript type object. I can put it here. I can put it here. I can put it here. And that's it, inserting JavaScript document object as defined above, right? You can just put it in a square bracket and comma separated, and that's it. You can, write something like this, and it will insert these three documents. Simple. So query documents of universities in Nashville and Memphis region and arrange in descending order. So this is a query task. How would you do the query? Right? So first of all, you can create a cursor object. So you find what? Where city in Nashville and Memphis, and what? You want to arrange the documents in a descending order of what? The city. So by descending order, I mean alphabetically you are ordering.
So I think it will be -1.
Is it -1?
Yeah, descending is -1, I guess. That I have seen last time.
Okay, this should be put -1. Good catch. I think that's easy. So what do? So this is a JavaScript. This is 100% JavaScript, right? And then you have the print JSON. I'm not familiar with print JSON. Those who are familiar with JavaScript, they know whether there is a print JSON method in JavaScript. Then you say print JSON, and then you put cursor to array. So it will print the document in JavaScript array, and you will get to see things as needed. So this is 100% in JavaScript. We are doing everything else within our object-oriented programming language, within JavaScript, but everything else we're doing is related to database management. Okay. All right. So let's look into some update example. Update method on collection objects allows you to update documents following a query target documents to be updated. Right. So this is a syntax for update method, and there is a specific meaning. So first of all, you have to provide, whenever you are doing some sort of update, let's say there are some documents and you want to do some update in the document. So first of all, you have to use a query to identify the document. Then you update the document, and there are some Boolean conditioning. You will get to see those things. And you will create this object, use this object method to be able to update, and we will have this. And you have the reference manual once again, and this update is a method for collection objects. Once again, you will have plenty of examples in this link. You can go ahead and learn. Let's try to look into an example. So what is query part of this? So this is the query object that we have discussed earlier. You know what a query object is. You just specify the conditioning on your fields, whether it should be greater, salary should be greater than 1,000, whether you're looking for entries that are within a set of cities, and so on and so forth. Update, this is the update object that you need to specify the updates. We'll talk about that in the next slide, okay? And then upsert, which is a Boolean. If true, a new document will be created in case no documents match the query, right? So if you put it true, a new document will be created. If you put it false, it will not do in that way, okay? Multi, if true, all documents matching the query will be updated. Otherwise, only the first document will be updated. Okay, if you want to, so let's say I'm doing a query, and that query gives me, okay, this query basically satisfies 10 documents in that collection. So if I keep this true, then this update will be executed in all 10 of those documents. If I keep this false, this update will happen only in the first document. Okay. That's the idea. So this is the query example. Find all the documents where city is London, and set it to city. You have to set it to city means you have to update all the documents where city equals London to what? Update the city fields equals New York. Why? Because the company has been relocated to New York. That's why you have to update, right? So how do you write that? So once again, I color coded this thing, right? This is the query. right? This is my where clause, where city equals London. So this is the yellow coded region is the query object. So this is my query object. Then the green coded region is you have to set, right? So $ set city equals Newark. This is the update object. So wherever it satisfies that there is city is London, replace that with what? City Newark. And I'm having it false. That means we do not want to insert a new document at this point. We are interested if only the London city, London is existing, any document with city equals London existing, only then we will update. If that is not existing, we are not going to create a new document. That's why we put a false here. Why true? The true is we want to update all the documents that satisfy city equals London condition. That's why we're putting true here. I hope that's clear, very straightforward. So that's the update, okay? And that's why I have this query update, comma observe, and things like that. Manipulating document via object update object. So here we have a document object. Okay. So these are a couple of examples. Here is a document object, right? Where city is Nashville, area is 500. I don't know how many acres we have land here. County is Davidson, right? Semester we offer fall and spring. We do have summer, and this is the address. Okay. Now we have to do some sort of manipulation on top of this object. So we want to update the TSU document as follows: increase the land area by 100. So you have acquired new land, and you're going to increase the land area by 100, right? So this is going to be a 600. What is the next one? Update the zip by this one, right? So this is a wrong zip code. You want to update this zip code by this one. Replace, basically, you're going to replace this one. Rename the street field as road. Another interesting thing is you can rename this street field. You haven't seen this example so far. So that means you can rename the key to road, for example, okay? How would you remove the field county? So I want to totally remove this field county, okay? And add an item to the semester array. So this is an array. Did you see that? This is an array. And I just want to add an item to the array, which is called Maymester over here. So what I'm going to do, show you next is answer to all these questions. Okay. What you create is you create one single update object, and inside this object, you have the commands needed for all these objects. So how would you increase the data? Land area, you just use $INC, which is a MongoDB keyword, area column 10. It will be increased by 10. So this should be 100, right? I made a mistake. I mean, I was typing by myself because I didn't copy paste from anywhere else. I had to create this, so I can make mistakes. Update the zip. How do you update? So when you're using set, you're essentially replacing the value. And I have to use address.zip because this zip is a field inside address, which is a field inside this TSU document object. That's why I'm using address.street colon road. And I'm using rename, right? So this is a MongoDB specific keyword. This is another MongoDB specific operation. This is another MongoDB specific one. Unset, right? Why I want to unset? If I want to totally remove the field county, so I can just, get rid of this one. Push, right? I'm pushing a new value, basically adding a new value to this array. So this is what I'm pushing. Right? So this basically tells you.
Samad, I have a question. Now, how do you know that you're updating TSU?
How do you know?
Yeah, that it's TSU that you're updating.
Okay,
You just say update object.
Okay, what is the next step, guys? What is the next step?
Execute.
Once you create this update object, you have to pass this object where? In this update method, right? We covered this update method in the previous slide.
Yeah.
right? You pass this. So once you have to create all these update, and then you have to do a query. And this query will be written in such a way that it identifies only the TSU document. It identifies and probes only the TSU document, right? How do you do that? So you can write a query such that find where, I don't know, it should have
university equal to TSU.
Or yes, something equals TSU. Or if you have a name here, TSU, you can just find where name colon TSU. So this is how you query the object, so that this update will happen only on the objects that are satisfied by this query, right? And then you have false and true, and you know what is the meaning of false. False meaning that if something that I'm about to insert, something about to update, if that thing does not exist, false means I'm not gonna create a new one. True means what? In this particular context, that if there has to be some update, that update will be applied on all the documents that were identified by this query. Is that clear enough? Okay, so first of all, you have to create a query object, you have to create an update object, and these are just the Boolean setting, and you pass them to update method onto this collection object, and that's it. Armando, does that answer?
Oh, yes, Dr. Saman.
Okay, good. Do I have, okay, I have a save method. I have 2 more slides. So one of the things you can do is you can use this save method on collection object that can be used to serve dual purposes. You can do inserting and you can do updating, right? So this is, I'm looking for documents where the city equals Boston. And one of the things I want to do is I want to insert, so wherever else the city equals Boston, right? I have this Boston set of collections of objects, so collections of documents where the city equals Boston, and update with the state field, right? So I can create a state field. I can, for example, the state field was not provided for this set of documents. You can create a new state field and provide Massachusetts, MA, and you can do that pretty simply. And then save the updated subset of collection, right? Because as you can see, after doing this query, I will have a subset of all the documents that I have in the company collection. Why a subset? Because those subset of documents will have city equals Boston. There could be city equals Chicago. I'm not taking those. I'm being very selective about the documents that I'm finding or choosing for my collection. Okay, and then I just made some quick changes and quick update on there. And then what I can do is save the updated subset. So this is the updated subset, the call Boston, right? So the call Boston is a subset of company call, right? Which is understandable, right? And what I can do is I can save this subset collection where this change had happened back to the company call, right? Because this is my parent, if you consider, this is my superset, this is my subset, right? So this is kind of a parent, and a part of that parent, let's say this is the child. So I made some changes in the child and save it back to that parent or save it back to the superset. So this is what I'm doing, saving it back to the superset.
When you save it back, does it retain its collection property, or does it just become mixed in with the company collection? Meaning, is call Boston something you can retrieve again, or do you just search for things that are in Massachusetts or Boston?
So the call Boston will still be there in the memory. Am I right? Right. So
sure. But when you save it to the disk, is it any? Are the things that were in that collection, aside from having the state be Massachusetts, any different from the previously existing elements?
that will be updating, right? So,
Okay.
so essentially, the documents that have city equals Boston,
Mhm.
they will now see an extra field, this one.
Okay, but the collection Boston isn't referenced in any way in those documents. Collection Boston.
I feel
when-
like those are two separate entities, right? The
Okay.
collection Boston and company column, right?
Okay.
But when I'm saving this thing, it
Mhm.
will try to match.
Right, and
then it will save.
if collection Boston goes out of memory, all of the ones that were affected by the addition of Massachusetts.
No, if I destroy this one,
yeah,
that wouldn't destroy this one.
No, I understand that.
Right.
Is there any differentiation between the ones that you've pulled out and done the insertion of the state of Massachusetts to, in terms of they were once a collection? Is that recorded in any way, or do they go back to being just ordinary?
So isn't that a
documents?
copy? Isn't that a copy that we're creating? This is just a copy of this one. But instead of the whole thing, this is a subset. We're taking a copy here.
Right.
Right. And then we're using that copy to update the corresponding thing. So this save is actually serving two purposes. One is inserting. If it needs to insert something else, it's kind of inserting. And as well as by inserting, it's correspondingly, it's updating wherever there has been some changes made.
Okay.
Okay. Remove the documents, pretty easy. You pass two objects. One is the query objects, because first of all, you need to identify the documents that you want to remove. And for that reason, you have to launch some query, right? That's why. And then if you can put just one, or you can want all. So would you like to remove all the documents that satisfy this query, or just the one document that satisfies this query? So that's the idea. So query object to identify qualifying documents to be removed. You know what a query object is. And just one Boolean, if true, only one document will be retrieved by the query and will be removed subsequently. And if it is false, then all the documents will be removed. And then we have to delete documents in university collection, which we name as a uni collection, right? So first we get the collection. We have a collection object, and we use this collection object, use .remove method, and that's it. It will selectively delete documents from a collection upon a query. For example, remove all company documents that are located in London, right? So I have this collection object. I'm doing a query. So this is my query object. So it will remove those documents from this collection that have city equals London, and I'm having true here. That means I want all the documents to be deleted, not just one. Okay. Any question after this? I'm going to stop here because that's the end. I hope this was useful to some extent. The PowerPoint slides are posted on eLearn. And now